3D lists. So we know that Python doesn't really have 2D lists. It has lists that can contain other values, which themselves can be lists. That gives the impression of 2D lists. Well, that same idea can be extended arbitrarily. So you can take something that we're calling a 2D list and create a list of those, and what comes out feels suspiciously like a 3D list. Here's such an example. This that I've highlighted here is a 2D list. Here's another one. Here's a third. And we have a list of those, so this is a 3D list. When you access 3D lists, you have to get the dimensions. Well, the outermost dimension will be the length of the list will be the first dimension. The length of the first element will be the second dimension. The length of the first element of the first element will be the third dimension, and so on. What we've done here is we've done the dynamic lengths like we did in the last example with ragged, allowing us to have 3D lists that are actually 3D ragged lists. If we go ahead and run this, you'll see it goes through, and in fact it's accessing every single element in turn in the list. Just to be sure we can really see what's going on, let's go ahead and do this. Let's say A0 is that. All right. Then we'll do A1 is that. And then we'll do A2 is this. Fine. All I did is took the list out of this and out of the original list and made them each their own lists. So A1 is plain as day, an everyday 2D list. I mean, A0 is correct. It's a 2D list. A1 is also plain as day, a 2D list, and A2 is a 2D list which only has one row. So there's nothing new about A0, A1, and A2. And A is clearly a list composed of those 2D lists. I did it this way to make it extremely clear that A is nothing more than a list of 2D lists. This doesn't change the problem at all. When we run it, sure enough, it runs exactly the same way. So you can see that you can have a 3D list this way. And naturally, I could have a 4D list if I said B is some other list that maybe had A and some other 3D list that I had created, and B at that point would be a 4D list. So now we have arbitrary dimensional lists. This is not used that frequently in 112, maybe even not in general, but there are times certainly where you're going to want three-dimensionality. And you could use it, for instance, in 112. When we do Tetris, the shape of each piece is a two-dimensional list describing where a piece such as a T or a block, where the parts of that piece are. That's a two-dimensional list. Well, we keep a list of all the shapes, and that's a list of 2D lists. So there you go. That is a 3D list that we will use in 112. So it's used sometimes, just not that often.